And when we draw an angle is formed by two rays. That's a definition that you learned in geometry class. You need to show the direction that it's going. So you start at 0 and you show, and you go arrow here and be like, oh, this is starting at 0 and going in that direction. And then usually you put something there to show you what the angle is. And our go-to thing is theta. So I'm going to put a theta here and throw there. So that they use other letters. So that's my angle. This ray where it starts is called the initial ray. Kind of makes sense. Initial means like starting. And where the angle stops is called the terminal ray. You begin terminal and stopping. Okay, so when we see angles, you're going to see them like that. When I ask you to draw an angle, that's what I expect to see. If you don't put the little arrow there to show me which way it's going, then you're going to miss something on that. If you don't put arrows on the end of your angle, right? What else do I have? Just some random trig knowledge here. Trigonometry comes from two words. It comes from meaning triangle. That's where the tri part comes in. And if you're thinking about geometry, trigonometry, that comes from measurement. So pretty much most of what we're going to do this semester is going to be revolving around triangles. And maybe you remember from geometry class, right triangle trig, SOHCAHTOA, remember that? We're going to kind of build off that as we go this semester as well. But we're going to kind of go a little different than that. Oh my goodness, so let's draw another angle. Let's draw an angle in the third quadrant. There's my initial ray. And it doesn't have to be the exact same spot. It really doesn't have to be. And if I draw in my arrow like I did on this first one, if I start at 0 and I go in this direction, is that clockwise or counterclockwise? Counterclockwise? So if you do this, I'm going to call this alpha. If I do this, it is measured counterclockwise. Means that it will be a positive angle because we start at 0 and we're counting up. The reason that you have to make this little arc is because you can also start here and go in a clockwise direction. Let's call that angle beta, which is kind of like B with a little tail on it. Beta is drawn clockwise, and when you measure an angle in a clockwise direction, that's a negative angle. So that kind of goes against what you say in geometry. In geometry, we say you can't have negative angles, but that's a lie. Just like they used to tell you can't have negative angles. They lie. So if we, I should have picked an angle that we have. What would you approximate the degree measure of this positive angle? Definitely bigger than 180, yes? Not quite halfway in between. I want to say like 215, 210. But let's pretend that this is 210 degrees. So if we figure out what beta would have to be, what would beta be? How can we figure out what beta would be? Yes. And what would be left over if we take 360 minus 210? 150, but because we're going in the clockwise direction, it's actually measured at negative 150 degrees. And I did degrees because I know that's what we're most familiar with right now. We're going to be doing this with radians as well. Alright, so the direction that you're going determines whether your angle is positive or negative. Also, we can say that angles alpha and beta are coterminal angles. And that means, although they have different measures, one's 210, one's negative 150, if they have the same initial and terminal rays, then those are called coterminal angles. That's what it is. In this picture, yes. So alpha is positive and beta is negative because of the way I do it. Other questions about that? We get the same idea with radian. Instead of subtracting from 360, if you had a radian measure there, you would subtract from 2 pi, right? So if this was in radian and you wanted to figure out what this negative angle was because it was going in this direction, then you would subtract from 2 pi. So let's look at this breaking up a circle in by quadrant. Degree measure, I think maybe we're pretty good with, but we're going to write it there anyway. And then we're going to talk about radian measure. And again, you can always convert, right? Especially in the beginning here. If I give you radians and you're struggling with it, you can do the conversion. But I don't want that to become a crutch for you, and so I want to kind of try to help you think about breaking up the circle like we talked about yesterday. Is it bigger than pi? Is it smaller than pi? And going from there. And so we're going to kind of label this. So if you want to kind of a little bit here. First of all, I want to talk about quadrants. Remember that when we talk about quadrants, we talk about Roman numerals. So if I ever ask you what quadrant is this in, it's expected that you write the Roman numeral 1, 2, 3, or 4, not the number 1, 2, 3, or 4. So remember that this is quadrant 1, and then which way do we go to count? Do we go counterclockwise? Counterclockwise. This is quadrant 2. Degrees we're pretty comfortable with. If I said what quadrant is 300 degrees in, it's probably going to be able to figure that out pretty easily. But if I said what quadrant is 3 pi fourths in, maybe you're not as comfortable with that. And so that's why I want to draw this little picture for you to try to hopefully, not that this becomes a crutch, but that you can kind of see where this comes from and you could reproduce it. So let's do degrees first, because we're familiar with that. 0 degrees. 90 degrees. Going on around. 180 degrees. And this is 70 degrees. And we end back where we started, which means 0 degrees and 360 degrees. Those are coterminal because they're in the same spot, right? They would have the same angle. And we really could keep going. We'll talk about that in a minute, but we could really go bigger, but we'll just go through. So let's do radians, right? This is also 0 radians. Again, I think going to pi is the easy way to go here of saying this is pi radians. So what would be halfway between 0 radians and pi radians? 1/2 pi, or pi half, yes? Half of pi, I'm just going to write pi half. So think about any angle between 0 and 1/2 pi is going to fit in quadrant 1. So anything less than a half, so pi fourths, pi sixths, pi thirds, pi sevenths, right? Anything that you could write less than 1/2 pi would be in quadrant 1. Anything between pi halves and pi, so anything between a half and 1 whole pi is going to be quadrant 2. So that's going to be our 3 pi fourths and 3 fourths, 5 pi 6. Lots of thinking about your fractions here. And then what would be down here? If this is pi halves, this is pi. This is going to be a half more than pi. So we'll write down here. This would be like pi plus 90 more degrees, or plus pi halves. Pi plus pi halves equals Yeah, 3 halves, right? 3 pi halves, 3 halves pi. Almost every year someone says pi and a half, which is true, pi and a half. It's just pi plus another half, which is 1 half pi. So again, anything between 1 and 1 1/2 pi is going to be quadrant 3. And then from here, if we go back up, we get all the way around, right? Think about drawing a circle here. We get all the way back to the beginning, which is 2 pi. There are questions on your homework today that just say, what quadrant is this in? Degrees, you're pretty quick with that. Radian, if you need to do the conversion, you can, but I really want to push you to try to think about how it relates to pi first, and then if you want to convert it to check your answer, you can. But we really want to start thinking about how does it relate to pi and pi halves and 3 pi halves. Which quadrant would it be in? Is it closer to 2 pi or is it closer to pi? Okay? Alright. So look, I told you there's a lot of drawing. Let's draw that. Let's draw quadrant 1. Let's draw like halfway between the x-axis and the y-axis. So we already talked about that coterminal angles are any angles that have the same initial rate and terminal rate, which means you can always figure out what this is and subtract see, and you can find the rest of it, like the rest of the positive angle, or you can do the negative angle. You can always do that for coterminal angles. In terms of degrees, what would be the approximate value of this angle I just drew if it's halfway between 0 and 90 degrees? 45. What would that be in terms of radians if it's halfway between 0 and pi halves? Pi fourths. Half of half is a fourth. So we could say that this is about and again, most of my notes today I'm going to do in radians because I know that's what we're least comfortable with. Your homework goes in degrees too. And just know it's the same except for there's 360 degrees. So what if I did this? What if I started at the same initial ray and I went all the way around and stopped the same terminal ray? I'm going to wish you had that color. Could I figure out how much that angle measures? How could I do that? Because I went all the way around, which is 2 pi, and I went up that same amount, right? So if I wanted to find this, which I don't know what it's called, but if I wanted to say what is alpha, it would be pi force plus going all the way around, which is 2 pi. And if you struggle with adding with pi, remember it's just adding the numbers and then put pi with it. You can always just add on your calculator and put pi with it. But this would be like 8 pi. That would be 2 pi plus 1 fourth. On your calculator, you can just take 1/4 plus 2. Just 2 and 1/4. Do those meet the definition of coterminal angles? They share the same initial and terminal rates. And I think we could keep going. I don't draw this on your paper because it's going to get kind of crazy. But I could do it again, right? I could change colors here. And I could say, well, what if I started here and I went around twice and then I went back up? That's my 2 points, right? But I could just keep going around forever and ever. And so then to find the green angle, you agree I would just add 2 more pi to this. I would take pi fourths plus 4 pi. So I think we can say that every angle that you can think of has infinitely many coterminal angles, because you can always just keep adding 2 pi. Or you could go the other way. You could go clockwise and you could keep subtracting 2 pi. And you could give me the negative angle. So a common question that like show up in books all the time is, give me 2 coterminal angles. Or give me 1 positive and 1 negative coterminal angle. And usually for me, I go plus 2 pi minus 1 pi. But if you really want to make my life hard, you can add like lots of pi, right? Any multiple of 2 pi, and that's still a coterminal angle. That is right. So we can write out that if you want to find all coterminal angles, right? You couldn't list them all because they go on forever, but we could write it very mathematically. All you have to do is take your angle and add any multiple of 2 pi. This kind of goes back to 2. Remember that V means integers. So it means like any multiple of 2 pi. That's what 2 pi n means. Where n is an integer. That means you could add any positive multiple of 2 pi, any negative multiple of 2 pi. We could write the same formula in terms of degrees, but instead of saying 2 pi n, what would we have to be multiplying by? What multiple? 360. So you can add or subtract any multiple of 360 degrees. It just means where n is an element of n cube. That just means where n is an integer. N is an integer. Okay, so let's practice. And again, I'm going to practice the reading. You don't have to draw there. Alright, so I just wrote find a coterminal angle. Sometimes I might ask you to find 2 coterminal angles. Again, there are infinitely many answers here, so your answer may be different than someone else's answers, but as long as you are adding or subtracting a multiple of 2 pi, that's what I think of. So on this first one here, 11 pi over 5, here's what I usually think about, because I like to think of angles that I know. Is 11 over 5 bigger than 2 pi or smaller than 2 pi? It's bigger, because isn't 11 over 5 bigger than 2? So for me, on this one, and you don't have to, you can add 2 pi and just keep going around more. For me, I'm going to subtract 2 pi. We're going to talk about as we get into trig more. When we get into solving trig equations, and that's not very exciting. When we get to solve equations, a lot of times it says you have to give your answers between 0 and 2 pi. And so that's kind of why my brain works that way. When I see 11 pi fifths, I think, oh, that's bigger than 2 pi. My answer is allowed to be bigger than 2 pi. Sometimes. So again, you can use your calculator and just do that. Or maybe you can just think already how much bigger than 2 pi is this. Or good old-fashioned common denominator here. That would just be 10 pi fifths. Okay? So that's just 1 pi fifth bigger than 2 pi. So 11 pi fifths is the exact same location as just pi. It is not wrong if you add 2 pi. It is not wrong if you add 100 pi. It's not wrong if you subtract 262 pi. As long as it's a multiple of 2 pi and you add or subtract correctly, you're going to get a coterminal angle. I just changed 2 pi. I forget who it was, but someone a few years back always on their test or quiz for this, always get a gigantic number of 2 pi. Just because they want to check that they're accurate. Okay, so I'm going to let you do pi thirds and negative pi ninths for a minute. Your choice. Add 2 pi, subtract 2 pi. Add 4 pi, subtract 4 pi. I don't care what you do. Except for, like on number 3, I'll give you the hint. I'm going to add 2 pi to make it a positive angle. Again, but on this one you can do it. But again, you can do it. So sometimes in math, it's going to look at one and there's something. Either one. Yes. Or any multiple of 2 pi. Coterminal means we want to just go around it again. Yeah, so, yeah. Because you can't reduce that. We just want to kind of go around that circle again. I kind of skipped number 3 first because it kind of fits that category. Why would I want to find a coterminal angle? If the direction said you had to give your answer between 0 and 2 pi, and you solved it and you got a negative angle to make it positive, really easy, all you gotta do is add 2 pi. This one's already a lovely angle, pi thirds, lovely quadrant 1 angle, but to find a coterminal angle, if you add 2 pi here, right, that's 6 pi over 3. And then again, your answer, if you didn't add 2 pi, if you added 4 pi, or if you subtracted what I added, you might have a different answer. But those are all correct answers if you're adding or subtracting correctly. I do want to remind you that there is going to be a no calculator portion of our test. And not that I'm going to put terrible computations on it, but being able to add or subtract 2 pi to an angle is definitely an expectation without a calculator. So just make sure that that's why I show the work here of making sure you know how to do that. So I would say, even if we don't learn radians, I'm going to teach you how to do fractions. Something else we can talk about, complementary and supplementary angles. Anybody remember from geometry what complementary angles mean? Supplementary angles? Which one? Complementary, supplementary, do you remember? Switch it. Supplementary add up to 180, complementary add up to 90. I always remember that in geometry when I was in school because alphabetical order C comes before S, and 90 smaller than 180, that's my favorite. I just remembered it. Same thing's true still, only we want to talk about radians as well, right? I hope that you would be able to convert it to degrees. Two angles that add up to 90 degrees are complementary. We can also say that 2 angles are complementary, alpha and beta, if they add up to, in radians, 90 degrees. What is in radians 90 degrees? Pi halves. Or also next to it, 90 degrees. So, there's questions on your homework today that say find the complement, find the supplement. It just means find the angle that makes it add up to pi halves or makes it add up to 90 degrees. And so I think my other one here is supplementary angles. Supplementary angles, alpha and beta, are 2 angles that add up to equal pi. Plus, I thought if I'd not pretty close today, I would be right. Good 40. And the ring. Tomorrow 43. Okay. Bring next week to high school. One high school. Did you see the Powerball? No one hit the Powerball last night. Projected for Saturday, $675 million. I know, you shouldn't buy the ticket because all these people bought tickets and no one even won when it was for $500 million. What do you get for $500 million? It's not bad, right? I haven't bought a ticket. This is hard to even buy the ticket. She never buys a ticket. Here's my TA in geometry, and I forgot to tell you guys, like, I remembered when he was my TA, I was like, I meant to tell you guys that it was up to 500 and that I almost bought a ticket standing in line at Kroger, and I didn't, because I was like, I'm not going to win, like, I'm not going to waste my money. Because Todd never buys a ticket, and she thought they were still $1, but they're $2. They've been $2 for a very long time. She's like, I didn't know it's $2. So that's so high, it's really hard not to waste $2 on it. My husband said it's all rigged anyway because they know all the numbers that are there until they know immediately because it's not, it's supposed to be rigged. Alright, so here's I think the last thing. Is I want you to sketch the angle with practices drawing, but also with practices thinking about what these angles are. And again, I really want to push you not to convert that to degrees, because you can't. You can convert it to degrees and then you know where it is. But I want us to kind of think about, in terms of radians, how we can figure out where it is. And then if you want to check with degrees and make sure it's the same one, we can do that as well. Alright, so first of all, 5 pi force is a positive angle, so we know we're going to be going in a counterclockwise way. And we know for sure that our initial rate starts here at 0. So that part you can start for sure. So now let's think about 5 pi force. Is that bigger than pi or smaller than pi? Bigger, because 5 over 4, think about that's like 1 1/4 pi. So if you just think about this being pi, as far as knowing this is pi halves, we even said earlier, halfway between pi and pi halves is pi fourths, right? So each one of these is like a fourth. So 5 pi fourths, wouldn't that just be a fourth more than pi? Which I think should be directly in the middle here. If you convert that to degrees, you get 265 degrees. It's not labeled with the theta, so you don't have to put theta here. If it says this equals theta, then you want to put theta here, or you put that theta. But if it's not labeled with an angle, I would. Questions about that? Negative 2 pi 6. And again, I want you to try to think about where would it be. And then if it helps you and you want to convert it to degrees and use that to help you check your answer, you can. But I want us to try to do it without doing that first. So I'm going to draw my initial rate. Negative means I'm going in this direction. So think about if we're going negative now, right? So this is going to be negative pi halves. This would be negative pi, right? I would just relabel going in a negative direction. So 2 pi thirds, is that going to be more than pi or less than pi? 2/3 is less than 1 pi, right? And so another way to think about this is in terms of fractions. Think about the good old days of elementary school. If this is 1 whole pi and I want 2/3 of it, do you agree that you can kind of just imagine breaking this whole bottom half into 3 parts and you want 2/3 the way around? So like I don't so I think this would be like 1/3 roughly. That would be roughly, it's a little off, but that would be roughly 1, 2, 3 equal parts. Which means if I wanted 2/3 of the way around, I can say, roughly speaking there. On a quiz or a test, if I make you draw an angle and you're off a little, right? Like maybe you draw it here and really it should be like here. I'm not going to mark that wrong because it's a sketch. What I'm looking for is it's generally in the right area. Okay? If you're in the wrong quadrant, that's a big deal. If you're going in the wrong direction, that's a big deal. But generally speaking, in the right area, you're going to get your point from. Met. Yes. If you're going in a negative direction and coming around, this would be negative 2 pi. You would just go clockwise. And if you convert that to degrees, I think it's negative 120. Alright, so I just want to, again, say think about it in terms of radians because we're going to be using radians way more than we use degrees. You don't want to always have to be converting to degrees. Alright, so your homework today is actually from a different textbook, which means I'm calling it packet homework because it's just a textbook copy of a page, and then you're going to do it on other pages. So here are my rules before I give you the packet. If the problem is in degrees, I want your answer in degrees. Right? So if it says find the complement of 30 degrees, I want you to say 60 degrees. But if it says find the complement of pi thirds, I want you to find that in radians, and then your answer would be pi sixths. And so make sure that if it asks you for degrees, I want the answer in degrees. If it asks you for radians, I want it in radians. Now the exception to that would be if it says convert, right? If it says convert from degrees to radians, then you have to do that. But most of the problems today are not that. They're what quadrant is it in, find a coterminal angle, find a complement, sketch it. And so I really want to, like, those are the rules I want you to use. So, I just have this from a different textbook, and I actually think I have I think you should. If you can fit, if you write really small and you can fit all your stuff here, if you want to write it on there, you can. Just make sure that I can find it on the day of the test, or in homework, please make sure you can find it there. So, first of all, notice there's 2 1 through 10s, so the first part is vocabulary. Do not do the vocabulary check. 1 through 10, so you're starting with the number 1, I guess the number 7 down there. Number 7 at the bottom here, that says determine the quadrant in which each of these lies. So, if you can write small and you can keep track of it and you want to write it on there, you can. My hope would be that you can do it on the first paper, but welcome to go through and circle those that have a second, let's just put this go into the second one. As you can see from this, we are only doing sections 1, 2, and 3 before we have our part 1 test. So we'll still spend this lesson worksheet built in there. Probably looking for the week of Martin Luther King Day that we would have our first test. But just kind of give you a heads up on Alright, you have some time to work. If you have questions over other homework that you still somebody's answered, it'd be a great time to do it. Otherwise, at least get started.